Hi, in the second part of the Launch Assist System Explained, we are going to see how the LAS technology could make the space launches more cost-effective, and we are going to give you an update regarding the Mission 9 launch in the context of the current emergency situation. As explained in the previous episodes, the LAS engine's performance is lower compared with the ones using classic propellants, but we found it ideal from the cost, safety and care for the environment points of view to assist the launch of current rockets. LAS is basically a lifting vehicle that is carrying orbital rockets at the launch altitude using only hot water as propellant, allowing a major cost reduction of orbital launches. Built in the corresponding size for the lifted payload, it can carry any orbital rocket to altitudes of around 3000 meters and Mach 2. LAS can be used both as a first stage as well as a booster for any current 2 or more stages rocket, while allowing the increase of its payload with up to 30% or the reduction of the use of polluting propellants with up to 25%. In the case of ARCA's HAS2CA SSTO rocket, attaching the LAS as first stage, it allows the increase of carried payload from 100 kilograms to 600 kilograms. But of course, the HAS2CA design, being an SSTO, is not as efficient as a rocket using multiple stages. Or for the same payload of 100 kilograms, using LAS as a first stage, it will allow the reduction of polluting propellants from 60 tons to only 6 tons, which is 62.5%. Currently, the engines and tanks used at takeoff are of course the largest and inherently the most expensive parts of a rocket launcher. The use of LAS could replace these expensive polluting first stages or boosters or work in conjunction with them. LAS will be built in two versions, an expandable and a reusable one. In the case of the expandable version, this will use a non-steerable bell-shaped nozzle engine, although we are analyzing the possibility to reuse these vehicles by recovering them via parachutes. And the reusable version, that is using an Aerospike rocket engine with thrust vectoring control, as we are going to see and demonstrate in flight during the upcoming Mission 9. So we are going to talk next about three scenarios to use the LAS technology. Case study 1, enhanced payload capability. Depending on the rocket that is analyzed, the use of LAS strapped on the vehicle airframe could lead to an increase of rocket payload capability from 20 to 30%, as we can see in the case of Atlas V 500 and Falcon 9 rockets. Case study 2, reducing the load of first stage's polluting propellant. By using the LAS technology, the current rockets could reduce their first stage polluting propellant mass and of course the size and weight of their first stages while keeping the same payload capability. Again, depending on the analyzed rocket vehicle, the use of LAS technology could allow the current rockets to reduce their polluting propellant mass with around 25%. As mentioned before, this will of course lead to a reduction of tank length and of course weight. And in the case of multiple engines first stages, like in the case of Falcon 9, this will lead to a decrease in numbers of these expensive polluting engines from 9 to only 6 or 7. Case study 3, replace current toxic propellant boosters. The expensive current boosters are using solid propellants and their byproducts are toxic. LAS can dramatically reduce the cost while keeping the environment clean, as we can see in the analyzed cases of Vulcan, Ariane 62 and Delta IV medium rockets. Depending from case to case, the LAS could completely replace or work in conjunction with boosters that are using solid propellants, of which byproducts are toxic. In conclusion, we are convinced we found a way to make the space flight safer and more cost-effective while protecting the environment. And we are going to demonstrate the LAS technology in the upcoming Mission 9. Speaking of which, let me give you an update regarding the upcoming Mission 9 flight for the LAS technology. As we all know, there is an emergency situation, or whatever it is called depending from country to country, caused by this pandemic that pretty much affected the economic activity around the world. Mission 9 was supposed to happen this month, so in April, but because of this lockdown, we were pretty much forced to reschedule. We started the official negotiations for the LAS-25DA rocket launch with the Air Force to launch this vehicle from an Air Force base, but these days the Air Force is more focused to fight this virus that affects us all. I don't want at this point to give an exact timeline because it depends on how the situation is going to develop, but at this point I hope for the end of May. Another good news is that because of the emergency situation and reschedule of Mission 9, the team resumed the work on the HAS2CA rocket that is going to be used as a second stage for the LAS booster. And that's it for this episode. In the next episode, we are going to give you an update regarding the preparations for the Mission 9 flight. Don't forget to subscribe to this YouTube channel and support this video series on Patreon. Stay safe. See you next time on Flight of the Aerospike.